Hey guys, I'm going to dig right into this Zenith Bug Eye set, and let's see if I can get this set running in one night. First thing though, I want to check the picture tube, because if it's bad, well, that's the end of that. So I've got all my connections set up. And let's see, adjust the filament for 6.3. Yeah, it's glowing. Good. Shorts. Cut off. It's climbing. It's good. Emissions in the bad, but steadily rising. I looked up the data on this picture tube, and this is the 14XP4A, and the A is aluminized. So I really hope I can get some halfway decent emissions, because with that aluminized screen it should be a nice bright picture. I let the filament cook at 7 volts for about 10 minutes. Now let's see what we got. A very responsive cutoff. Set that in the black box and check the emissions. Alright, we're in the green. Life test. Fair. Alright, so got a good picture tube. I do have the original Sam's photo fact as well, so no issues with documentation on this set. A few videos ago, somebody left a comment asking me how I go about tackling sets. Like, do I have some kind of plan or a checklist? Sort of. What I did with this set in particular is I had the SAMs, and I went through and looked at the parts list, and I placed an order for any of the parts that I didn't have on hand. I keep all the common values in stock. Like, I've got a whole range of half-watt resistors and standard 630 volt axial plastic film capacitors. What I generally look for is high wattage resistors, like this column here. If there's no marking, it's a half watt, so those I pretty much just skip over. But when I see things like 2 watt, 4 watt, 7 watt, 5 watt resistors, that's what I order, because I don't generally keep any power resistors on hand. And I usually order up the electrolytics as well, so that's why I've got this bag here. So I'm going to get to it. Turn off CRT testing, get it out of the way. And then I want to see if I can indeed recap this set without taking it apart any further. Oh, and while I go through and replace the components, I'll tick them off the parts list here. What I'm going to be replacing is all the electrolytics. You have 1, 2, 3, 4, 5, 6, 8 altogether. And the plastic, or all the old paper capacitors, I'll replace those with plastic film caps, and I'll just take a highlighter and mark them off as I do them. The micas and ceramics I don't generally bother with or test until I've replaced everything else, and if I still have problems, then maybe I'll start looking at the micas and ceramics. I had mentioned in an earlier video that this set appeared to have one more tube than the 1958 version, and indeed it does. And what that's used for is a horizontal phase detector, and then there's a horizontal AFC, automatic frequency control, and then there's a horizontal oscillator. So I think this design is actually superior, even though it's a year older than the other Bug Eye. What this means is that there's no horizontal hold control. Or rather, there's just a coil, and you just adjust that internally, so it's the free running frequency, and then there's no horizontal hold control for the user to adjust. Whereas the other set has both that coil, and then a coarse horizontal control, and a fine horizontal control. So that set actually has 3 horizontal hold controls, whereas this just has 1 coil inside, which is down in here. So I'm curious to see how well that works in practice. Assuming it does work well, I would imagine they took it out of the 58 model just to save costs. It's one less tube. Also, with the addition of that extra tube, the dropper resistor in the series filament here, it's only 17 ohms, whereas on the other side it's 27 ohms. Because I need to dissipate a little more voltage in that set, whereas this, they have a tube that's taking up some more of that voltage. Alright, so it turns out that I can work on this set without taking the picture tube out. It's possible to set it up so the picture tube's pointing straight up and it's not putting any undue strain on anything, so see how far I can get with this. And just like the other set, this one has those little solder cups, which do make it easier to work on, so I'll show you how easy it is to get these components out. Start with this cap right here. So I just take my soldering iron and just plunge it down into that cup. Wait for the solder to melt. Pull out the lead. There we go. Now the other one happens to be wrapped around a terminal, so I will have to undo that. But most of these caps at both ends go into those cups. All I do is heat up both ends, pluck that guy right out, and stick a new one in. Here's my new cap, 0.1 microfarad, 400 volt. Sometimes I don't get 630 volt caps if I can find some more reasonably priced lower voltage ones. Still plenty over spec though, because the original was 200 volts, so 400 volts. Gives me some nice headroom. Plus I like buying name brand caps when possible. This is a Mallory branded cap. Just a little bit of heat shrink tubing over the leads. One thing I don't like about these solder cup construction techniques is that there's a lot of potential for component leads to short out. Notice a lot of the original ones have these sleeves over them. So I'm doing the same. Goes over here. Once you heat up one of those cups, it looks a little bit different. It kind of burns off the dirt and dust and so on. So I could tell where the old part came from. Tin the lead up a little bit. Heat that cup back up. Shove the lead down in there. Alright, it's one down. I'll just keep doing the same on the rest of the parts. I finished replacing all the old paper caps and a few resistors I found that were especially far out of tolerance. For example, this should be 390 kilo ohms, and this was measuring over 600. Most of the resistors were pretty close to the stated values though, so I only had to replace those 3 so far. Now as for working on this set with the picture tube still installed, it certainly is possible, but it was tight in spots. For example, on this side I actually temporarily unmounted the support bar here, and I'm propping it up with a piece of 2x4. I had to disconnect one wire from this control to do so, but that really opened up this area and let me get down in there. Next up, I want to tackle the electrolytics. We've got a 3-section can here, 1-section can up here, and a 4-section can down in there. over here, this is the power supply, just like in the other bug eye set, and I'm going to do the same thing on this set that I did on that one, which was remove the selenium rectifiers and then mount the terminal strip. I can see there's a screw going right here that's what those seleniums are attached to, so I can reuse that hole them on a terminal strip, and I'll install 4 new electrolytics and replace this with a proper fuse and resistor. As for the other guy, it's a 4-section electrolytic, similar to the other bug eye. I'll try doing the same thing on this one I did on that, which was to simply relocate the 4 electrolytics as needed. For example, I can see there's a yellow wire here. It's going right from this lug over to this tube pin. I can simply remove this wire and attach the new capacitor, one lead there, and then the negative attached to the chassis. I just finished installing all the new electrolytics with those selenium rectifiers out of the way. Had plenty of room. Also took the old filter cap out. So now we've got a fuse, a couple of modern silicon diodes, some nice new caps. And the others are scattered around down in here. We got one there, one there, one there, and final one is tucked down there. Alright, so time for a power-up. I'll use Variac and isolation transformer, and I'll put a 150 watt light bulb in series for the first power-up. Before I plug this set in, I remembered I wanted to do a resistance check, so I got an ohm meter hooked up right to the AC plug here. I'm going to turn the set on, and we've got a resistance of over 5 mega ohms, which is much, much too high. It should be more like 1,000 ohms or less. So I'm thinking we've got a bad tube, or at least the tube is not making good contact, because if all the tubes have good filaments and they're connected in series, the resistance should be much, much lower than that. Now I know the CRT's good, but I don't know about any of these other tubes, so I guess I'll just have to start chucking them one by one. Eventually I tracked down the problem, and it was just a loose tube, so here we go. Plugging it in and turning on the power. So as with the other bug eye, I've got a 150 watt bulb in series just in case there's anything horribly wrong. And I've got a voltmeter on the main B plus line, which should be about 245 volts DC. Well, that's promising. Bulb lit up and down, the tube filaments are lighting up. We've got B+, it's in the right ballpark. A bit lower now, but of course I got the bulb in series. And we've got buzz. Not responding to the tuner though, but that voltage is pretty low, so I'll try another power up without this bulb in the circuit now that we know there's no dead short. Okay, here goes. And that sure sounds like high voltage. Ooh, I see we have a line, but we have no vertical. That problem seems familiar. Hopefully more bad controls again. That's the brightness control. Hearing some pretty nasty arcing corona-like sound as well. tuner's working now. Turn that off. So I'm hearing some horrible arcing. It sounds like it's coming right from the high voltage cage, so I gotta check that out. And of course we have no vertical. That happened with the other, so it turned out to be a bad control for the vertical hold. Could be the same problem in this, but I'm not sure which of these controls is vertical hold. Oh, I see somebody's written little notes on here. Ooh, I can really smell that ozone now. So that's brightness, vertical hold. No, vertical linearity. Has a vertical hold, the one that has a little, I stuck a little knob on there. So let's check that control. But before I do that, I want to take a look inside that high voltage cage. Here's a look inside the flyback cage. Looks really clean to me. Flyback's in good shape, other than some dust. A couple minor cracks on the insulation, but it's in better shape than the other one. So I'll check for arcing in there. I also noticed that this red wire down in here was pretty close to that high voltage anode lead. So that might have been where the arcing was coming from. I just moved it a couple inches over so it's out of the way. I'll try turning the set on again and turn the lights off. And if there is any more arcing, hopefully I can find it. Yeah, we definitely still have arcing. I'm not sure where it's coming from though. Oh, now I see it. Okay. That should be an easy fix. It's right at the bottom of the flyback. It's down in here. I think it's just from all that dust down there. And looks like some of the insulation is falling away. So I'll just try cleaning that out for now. And later on, I'll try taking this cage off. Looks like you take out some 1/4-inch nuts and pop this off, and put a little Corona dope on there. It's kind of like clear nail polish, but it has a really high voltage insulating properties. Some compressed air. Let's see if that helped. Nope. Alright, yeah, I better do a proper job on that and get some of that Corona. It turns out this is going to be a little bit trickier than I had anticipated. Simple enough to take off the 1/4-inch screws that hold on the cage. It's loose now. Just one problem. The flyback and high voltage rectifier are attached to this metal box. Rather crudely too. And they're just have metal tabs that run through and they're twisted over, so I thought I would just lift the box off and expose the flyback, but no, because the flyback is attached to the box. What to do? Perhaps I can just twist back these two tabs on this very crudely made box. Yeah, okay, I see. So the side that's all covered in cadmium oxide corrosion, it looks like there are 4 tabs from the other side, which is a U piece of metal. So if I pry those 4 tabs, so then I probably just take this side off. Okay, that actually turned out to be pretty easy. Just took some pliers, straightened out the tabs, and the whole box just fell apart. So get inside there, no problem. And as we can see, insulation is gone, or at least fallen away from the bottom. And that's exactly where it's arcing from. So this is going to need a little bit more than Just some Corona dope. Get out the RTV silicone and recoat this whole donut. I started cleaning the old outer coating off the flyback, and I quickly found where the arcing was coming from. So it not only was going through a crack in the outside layer, but it actually burned a hole through this inner, what appears to be some kind of clear plastic. So I'm going to put a dab of the Super Corona dope right on that hole, then continue to pick off this outer coating so I can recoat it with some silicone. As I had hoped, the tube of RTV-133 I had opened up a couple months ago was still just fine. It was just a thin scab of hard material over the end of the tip. I just had to scrape that off and it came flowing out just fine. So I have recoated the flyback. Oh, and before I recoated the flyback, I did let this thing cook in front of a convection air type space heater for about an hour. Not only to drive any moisture out of it, but also to cure the Super Corona dope. I looked up the specs for this stuff online, and at just room temperature, it takes a full 72 hours to cure. But at elevated temperatures, that time drops off drastically. I don't remember the exact numbers, but it seemed like at the temperatures that my space heater put out on high, that it would take about 60 minutes, so that's what I went with. As for this coating, it's been about 5 or 6 hours since I put it on, and it's cured up quite nicely, so I'm going to start reassembling this, and then I'll tackle the vertical deflection issue. I just finished putting everything back together and put the tubes back in that area, so let's see if that solved the problem. Now, if you ever do have a set that loses vertical like this has, definitely want to keep the brightness turned way down and try to run the set as little as possible so you don't put a burn in the screen. Alright. I got a nice trace on the screen. I got the brightness down low enough that I can just barely see the trace. And get the sound down. And no arcing. I hear a little ping occasionally, but I think that's just from the horizontal output tube heating up. So there's some pretty hefty power resistors back in that area too, and I think I'm just hearing just the usual pings you hear as metal heats up. Certainly no arcing and no smell of ozone like before, so I think that was a successful repair. Alright, so now onto the vertical. Oh, I checked the vertical output transformer, which I believe is that guy. And the vertical oscillator and the vertical output amplifier. Oh, and the vertical sections on the yoke. I think I may have just found the problem, or at least I found a problem. So I tried swapping out a few different 8CM7s, made no difference. I checked the resistors, they were all within tolerance. I did some voltage checks, and the values were definitely out of whack. Checked the vertical output transformer, that was okay. I checked the various potentiometers, they were okay. So what's left? Capacitors, or possibly wiring errors, bad tube socket connections, and so on. So I started tracing out the connections, starting at pin 1 on the tube and going all around. Well, I finally got to pin 6. I was checking what was going to pin 6. Well, got a .033 cap, and resistor on that side was fine, and it goes into this couplate vertical integrator. That seemed to be okay, so I went the other way. Vertical size control, yeah, that was okay. 0.1 cap, yeah, that's okay. What goes to the other side of the 0.1? Well, it should go to a 220 ohm resistor and a 2.2 mega ohm resistor going to ground. Well, let's see what we got. Here's that new cap right in here. That 104K, that's a 0.1 microfarad cap. This end of the cap goes to this wire, which goes over to pin 6 on the tube, so that's okay. Now the other end, what's it going to? It's going to a 100K resistor. Here's the 220 and the 2.2 mega ohm resistor going to this little solder cup. So I think what happened is when I replaced this capacitor, this lead is supposed to be going over here, but I've got it going in here. So I just heated up my soldering iron. I'm going to lift up this lead, stick it into this solder cup, and try firing up the set again. That looks promising. Brighten this up a little. Alright. Let's see. We got a vertical hole. Let's see what horizontal hole. Alright. Let's say I don't have much of an antenna hooked up, but there we go. Vertical hold isn't quite right. Seems to be going around. Let's see. Try the height control. Usually the height, the hold, and the linearity controls all interact, so you have to futz around with them. The linearity control on this is a pretty chewed up pot too. The shaft is kind of partially broken off, so I'm replacing it. That's what I'm adjusting right now. Height. I've been adjusting those 3 vertical controls, and I've also hooked up a scope to a critical test point to try to tell what's going on. I've got the scope right here. And it's supposed to be 60 volts, peak to peak, 30 hertz. Well, if I adjust my cursors here, according to my scope, I've got 90 hertz. And I've also been able to get 120 hertz, but I can't get down to 30 hertz. So the resulting effect is vertical oscillators running at multiples of 30 hertz, higher than it should be, so that's why we got these multiple images superimposed. Now if I adjust the horizontal hold, you can see I can vary this frequency. So now it's much higher, and now it's getting lower. But it bottoms out at around here, which is 60 hertz. That's the lowest I can get it. And notice it's unstable, it's jumping around. Of course, the picture's rolling. If you listen, you can hear some kind of weird, like almost an irking sound, coming from somewhere around in here. I think it might be a bad vertical linearity control. The shaft is kind of broken off on this and it's really hard to turn. I think it might be some arcing inside that control. But it's close. So I've got this control at 1 maximum extent. That's the horizontal hold. So let's see if we go to here. 750K going to ground. So I'm curious, do I have it at this extreme, so it's 750K going to ground, or do I have it grounded? If it's at the top extreme, maybe this control is not giving me a full 750K. And let's see, where's the linearity control? That's this guy. So I want to double check on that one too. It's what, 3.5K. A little bit of an oddball value, but I can check on it. I don't think there's any kind of excessive voltage in here though, so I don't know why there'd be any kind of arcing in there. Or I thought it might be arcing that was somewhere over here. it says do not measure. There can be a pretty hefty kickback from these vertical output transformers, like maybe over 1,000-volt spike. Pretty much it just goes to a resistor there and then a cap. And notice I don't give you any signal or voltage info from in here. I guess I can check this signal now. See, pin 8. Although, you know, we know if this frequency is off, this frequency is going to be off too. So first I'm going to double check those controls. Alright, one thing I found out right away is that this 750K pot is topping out at only 642K. And that's the position I've got it in when I'm getting close to the right frequency. So I should be able to have another 100K of resistance that I can add in when I go counterclockwise, but it's not. So what I can simply do is add about 100, maybe 150K in series with this pot. That's this wire going down here. Goes to a 330K resistor, which is this guy here. So I can simply pop this out and put like a 510K resistor in there and see if that helps out. I did find a source for these types of potentiometers. Anti-Electronics Supply has them, but they only have 250K and 500K, no 750 or 1 mega ohm pots. And by this type, what I mean is potentiometers that don't have that threaded inner mounting. They just have these little twist tabs. So you stick these through slots and twist them over and they have a little plastic shaft. So they're very low profile. So they don't stick up very high. They have to be like that or this won't fit inside the cabinet. If I put on pots that have a threaded shaft, they stick up yay high and this will not fit back inside the cabinet. So I want to salvage these as best I can. Now if I do go with a 500K pot, what I could do is put like a 250K resistor in series with it, which will work okay so long as the adjustment I want is always towards the high end. Now if I need to get more towards the low end, so I've got it like, you know, 50K, 25K, or even all the way down to 0, then you're going to be out of luck because it just you won't be able to go make the adjustment in this direction. But for now I want to get this set working, so I'm just going to up that resistor in series with this control. I just plucked out the old 330K resistor and I was getting ready to wire in a larger value when I thought I'd double check the wiring down in here and I found something that didn't look quite right. This thing here, which looks like a ceramic cap, is actually a couplate. You can see it over here on the schematic. It's this guy, K2. It's similar to those things that I showed inside the Predictus sets where it's a resistor capacitor combo. Forms an integrator. So here's that vertical hold. There's that 330K resistor. It goes to pin 7. But also going to pin 7 is this guy through a 0.01 microfarad cap. Well, when I look over here, this wire here is what's going to pin 7. Right now there's nothing going to that wire other than the 330K resistor, which I took out. Follow that wire around, goes over to pin 7 on the tube socket, and that's it, nothing else. Here's that 0.01 microfarad cap, which should be going to that cup over there, so it goes to pin 7. Instead I've got it going to this cup, which goes up to the vertical hold potentiometer. So not quite right, so I have to heat up this leg of this cap and move it over here. Then I'll put that 330K cap back in the circuit and let's see if it works a little bit better this time. Alright, let's give this another try. Let's just hold control, see if it works any better now. Ah, much better. The wiring errors will get you every time. Nice bright picture tube.
Secret Service agent. What's next? Come on, I'm waiting. Man of action. He's James West. Where's Jim West? On the Wild Wild West.
Cool.
Today at 4, 3 Central.
Alright, next up I want to test the tubes and then go through and finally check with the dropping resistors and tweak them or add them as needed to get the B plus and the filament current to where it should be. And then get a test pattern generator and do the usual tweaks for the linearity and so on. And then I want to try doing an alignment on this set. This is the first set I've come across where the service info indicates to do the alignment purely visually. Other sets I've worked on use a combination of a fixed RF generator to peak coils, and then you check the overall response curve. But this one in the SAMs, they say to hook up a sweep generator and just do everything visually. Just adjust coils to make it look like the indicated pictures. So it should be interesting to give to try that out. Plus, it'll give me a chance to use my B&K 415 for the first time. This is what I'm referring to. They tell you where to attach a sweep generator, a couple different test points here, and then they say to adjust certain coils to make the response curve look like these pictures.